Hey, welcome to day 4 as we investigate rational functions. Today's theme is we're going to be looking at finding the intercepts, the x-intercepts and the y-intercepts. And we're just gradually building and building and building. Each day we're looking at different characteristics of these rational functions. And hopefully tomorrow we're going to be able to put it all together and draw some really nice sketches of these graphs by hand. So where are we going today? In this video, by the time we're done, we're going to be able to look at this function right here, something like this bear, and almost, instantaneously in our heads be able to determine the x and the y intercepts. And that's what's kind of nice about all the things we've been doing this week, whether it was, vertical asymptotes, horizontal asymptotes, intercepts, domain range. A lot of these things can almost be done in your head without too much work or manipulation of the function. It's not like long division or something where it takes up half a page of work or something. Most of these are short and quick. So let's look at this rational function. And let me highlight this because I think the x-axis is very, very hard to see. Let me see if I can draw this. The x-axis is meant to be right here. Okay, and the y-axis is meant to be right here. So with that in mind, and I took the numbers off of the axes because I didn't want us to even worry about what the actual numbers were. We're just focusing on this more conceptually. How many x-intercepts does this function have? Well, there's going to be one right here at that x value and one right here at this x value, and those appear to be the only two. Now, what do they have in common? Okay, without knowing the exact ordered pair of those x-intercepts, what they have in common is they both have a y-coordinate of 0. Okay, so I want you to tuck that in your back pocket and keep that there. Okay, now let's consider the same function and how many y-intercepts does it have? Okay, what you'll notice is there's just one single y-intercept right there, and that's the most that a true function will have, because by its very nature, a function passes the vertical line test, and in this case, it would be impossible to cross the y-axis more than once. Now, what's true about this point? So without even knowing the exact ordered pair, the one thing that we could promise each other is that the x value is going to be 0. So we'll stick that in our back pocket. So here's kind of a summary of those intercepts. All right. When we talk about x-intercepts, the y value is guaranteed to be 0, okay, for any point that lies on the x-axis. So in a nutshell, if you want to find the x-intercepts of a function, we're simply going to substitute 0 for y, which in most cases is like us setting the function itself equal to 0, because usually that y is already isolated. Now, as far as the y-intercepts go, almost the same. Everything's just kind of conversely twisted around. The x value is guaranteed to be 0. And if you want to find the function's y-intercept, we just substitute a 0 for x. And I'm going to tell you what, of all the numbers that you could substitute for x, none of them are easier to evaluate in your head than 0 itself. It's really our best friend in a sense. Okay, so let's see if we can find the x-intercepts first. We'll draw ourselves a nice line down the middle and kind of split the work in half. So if I'm talking myself through this, if I want to find the x-intercepts, I'm going to take 0 and substitute it for y. So what does this look like? So this is my y value right here. So if I said 0 equals x minus 2 all over x squared plus 4, now that 0 could be written as 0 over 1, and then we could cross multiply. And when you cross multiply, when you multiply 0 times this expression right here, they cancel out and make 0. So in other words, every time you go to cross multiply, that denominator is going to get canceled, and we're just left with this expression. So in a nutshell, if you want to find the x-intercepts, all you got to do is set the numerator equal to 0, and we'll get x equals 2. So there's just one x-intercept. Sometimes there will be 1, sometimes 2, sometimes none. All right, let's see if we want to find the y-intercept. Talking myself through this, I'm going to take 0, substitute it for x. So now we know y equals 0 minus 2 all over 0 squared plus 4, which makes negative 2 over 4. And if we reduce that, we're going to get negative 1/2. And even though I wrote all that out, there's a lot of that, if not all of it, that you could simply do in your head. And I am A-okay with that. All right. No substitute for good reps. That's our theory today. Always tell Our students, we're not practicing until we get it right. We're practicing until we can't get it wrong. X-intercepts, we're going to substitute a 0 for y. And hopefully we anticipate that as we cross multiply, the denominator gets canceled. I'm going to go ahead and factor x squared minus 4x minus 5 into x minus 5, x plus 1. I think that works. So I'm getting two x-intercepts, one at 5 and one at x equals negative 1. For that y-intercept, we'll substitute a 0 for all the x's. So I got 0 squared minus 4 times 0 minus 5 all over 0 minus 2. That's going to make negative 5 over negative 2, which simplifies to simply 5 halves or 2.5. And again, you shouldn't come up if you get more than one y-intercept. That's a bad sign. That's a red flag that something went wrong. Something went wrong. All right, let's get her cooking here. So for my x-intercepts, let's set the function equal to 0. And again, if you can already anticipate that denominator is going to cancel out once we cross multiply, you can go ahead and skip that step for me. And then I want to try to factor 3x squared minus x minus 4. This is a tougher one to factor. We're going to do guess and check because of that leading coefficient being a 3. And the multiples of 3x squared are going to be 3x times x. Now I need to kind of do a little trial and error and figure out where do I want to put the multiples of negative 4 in a strategic fashion. I think we want to go minus 4 here and a positive 1 here. And if I multiply the outside and I multiply the inside and add them all together, I'll get that negative x in the middle. So I think we did well. So I'm going to get an x-intercept at x equals 4/3 and then again at negative 1. As far as my y-intercept goes, we'll go ahead and substitute a 0 for all the x's. Again, you do not need to write this all out. I'm just doing this for emphasis so that we can see the process, kind of what's going on behind the scenes. I'm getting negative 4 divided by 0, which is undefined, which means there are none. There are no horizontal, or I should say there are no y-intercepts, which probably means I've got a vertical asymptote at x equals 0, which I think we could confirm based on our last video that is the case. All right. Hey, that looks like that's the last example. How about that? So I hope we feel pretty good about finding x and y intercepts. And tomorrow when we come back, we're going to put it all together.